Okay, in today's flip session of chemistry, we're going to be talking about excited state configurations versus their ground state electron configurations. So what is an excited state configuration? Right, so when atoms gain electricity, gain energy, they could be an electric current could pass through them. They could be heated, right? And for whatever reason that they gain energy, their electrons can climb and enter a new, higher energy state. And that's what we call the excited state. So an excited state configuration has a higher energy than what's called the ground state configuration, when the electrons are at rest, so to speak. When they have one or more electrons occupying higher than normal energy levels than would be predicted, right? It's the essence behind fireworks, right? When elements such as copper are put into fireworks and shot into the sky through a canister, as the firework explodes, those copper atoms have high energy electrons that as they're coming down from those higher excited states is when we see light. And in this case, green light if it's copper. Copper gives off a green color, sort of like my shirt, almost like a teal. Okay. So examples of ground states versus their excited state. So the typical ground state for helium is 1s2. Right? The first shell has 2 electrons, and it's only s subshell. But if one of those 2 electrons gets excited, gets heated, electricity goes through it, one of those electrons climb and enter the 2s subshell, where they normally would not be found in their ground state. So see what we did here. We skipped to a new higher energy level before filling in the previous level. Once this electron does not stay excited and reverts back to the ground state, its configuration would once again be 1s2. Another example, neon, 1s2, 2s2, 2p6. The excited state, one of those 6 electrons in the 2p subshells would jump to a higher energy state, which is the 3s. So we would get 3s1 as its final electron configuration. So in other words, folks, if you're looking for excited states, you're looking for electrons that have not fully filled in previous subshells and jumped to a higher level. Okay, now you try. Okay, take a stab at this. Which of the following is an electron configuration in the excited state? So take a moment, pause the video, and try this. Okay, now we're back. Right, so let's take a look at the first one here. 1s2, 2s2, 2p6, 3s1. That looks like a ground state to me because every shell prior to my valence shell is full. Let's see, what would this be? 2, 4 electrons, 10, 11, that would be sodium in the ground state. Okay. Our next one here, same situation. Everything is filled in and we just have 1 more electron. So that would be 12 electrons total, and that's magnesium. Okay. Here's where we encounter our first excited state. Look what happens. 1s2, okay, 2s2. That should be a 2p6. One of those 6 p orbital electrons jump to a higher state. So this would be an excited state of 2, 4, 9, 10. This would be an excited state of neon. And finally, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now I know this looks a little strange, but remember, according to the diagonal rule, 4s comes before 3d. So this is normal, right? So this would be 2, 4, 10, 12, 18, 2025, I believe that is manganese. Okay. So our answer here would be C. That's the only excited state that we can determine. Everything else is in the ground state. Okay, and finally, this last slide here. What's the ground state versus the excited state look like? Okay, so the more shells an electron falls from an excited state to a ground state, the more energy is released. So in other words, let's say we had an electron in the first shell, right outside that nucleus. If this electron were to gain energy, let's say it climbs to the second shell, it's now in the excited state. And it's going to stay there until it loses that same quanta of energy, amount of energy. If it falls back down and reverts back to the ground state. So in other words, when we gain energy as electrons, we climb to excited states, and when we lose that energy, we release it, usually in the form of light or heat, and we go back to the ground state. Now, an electron going from the first shell to the second shell and then coming back down doesn't absorb or release as much energy as an electron that goes from the first to the third shell. That would be a greater amount of energy absorption. Likewise, if the electron came back down from its excited state, it would lose more energy. Think about it. If you fell from a step onto the ground, the amount of potential energy is not as great as if you fell from 2 steps. 2 steps would usually hurt more than 1 step. And that's ground state versus excited state.